This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Rahul Senanayake.
What's up, listeners? Welcome to Season 4 of Inspiring Design with Rahul Senanayake. This is where the best of the best brands, experts, change makers, and thought leaders come together to share their valuable insights, experience, and knowledge, all centered around the growth sector in advanced manufacturing within Industry 4.0, encompassing various industries, technologies, skills, knowledge, trends, as well as stakeholders, all the while linking it back into education within schools and universities. Welcome to today's tech-themed episode, and we have one hell of a ride in store for you. Today we focus on artificial intelligence and big data. And to talk about these technologies, I have here with me two bright young minds, Rahul Kota and Matthew Lakis. Rahul is a data scientist with a background in electrical and biomedical engineering, while Matthew is a mechatronics engineer with a specialization in simulation and virtualization, both representing an ambitious new startup called Athena AI. These modern day geniuses are both leading their fields with experience in AI and big data in a variety of industries, ranging from defense through to geospatial AI products, computer vision, mathematical programming, and digital twins, just to name a few. So without further ado, let's get straight into it. Welcome to Inspiring Design with Rahul Senanayake. Can we start off with a little bit of background about each of yourselves? What's your story?
Yeah, sure. So my name's Matt. I'm a mechatronics engineer here at Athena AI. Essentially, I've been working in advanced engineering for the past 3 years. So I graduated just last year, but for 2 years before that, I was working as an intern at firstly Australian Jointed Robot and then at a company called BMT and their automation team. And I focused mainly on computer vision, photogrammetry, that sort of thing. And then since coming to Athena, I've also started to learn more about artificial intelligence and big data, and also how we can use that data to create digital twins of environments and really visualize the sorts of things that you get out of the artificial intelligence. And I'm really excited to be taking that further here at Athena.
Impressive. What about yourself?
Hi, I'm Rahul. First, thanks for having me on, Rashan. So my story started as in uni doing electrical engineering. I did electrical and biomedical engineering. Didn't really like it, but luckily during uni I got some exposure to AI subjects and medical imaging. And through that, after graduating uni, I did work as a researcher at UQ, working with machine learning and MRI imaging. And through that, I then transitioned to work on normal vision problems like object detection and face recognition and things like that, which finally led me into my role here at Athena AI as a data scientist, where I work on applying the latest computer vision techniques, so things that will appear in literature, say like a month, and then quickly put that into our pipeline and try and keep us on the cutting edge of vision.
Yeah, wow. And how the heck did you guys learn how to do this stuff, in such an early stage of your careers?
Google.
Yeah, Google.
Yeah, I mean, similar to Rahul, so I started in mechanical engineering and I didn't really enjoy it that much. And luckily at UQ where I studied, they had Mechatronics Engineering, which is kind of a mixture between mechanical, electrical and software. And I basically used that to segue into software. I really should have done software from the get-go, but that was an easy way for me to graduate on time and segue from there. And really the way that I got into the field was through my internships. I was lucky enough to pick up a very specific sort of, job title, intern at startup, very small company type thing. And there's obviously a huge demand for their interns to really be putting themselves out there, learning things as quickly as possible. And eventually you figure out that the main part of the job, it's not really knowing what to do, it's figuring out how to do things. And then solving. From there, problem solving, but also like you're doing work that you can't just, employ random people to figure out how to do it. It's your job to, pioneer and discover new things while you're on the job. And a lot of that is actually done through Google. A little bit of your background knowledge from uni, but that's mainly a direction to tell you what to research.
Awesome. Well, we're here to talk about something very, I think, cool. It's very much on the cutting edge of the latest technologies in the world. One of the focuses I want to be able to discuss today is AI, artificial intelligence, as well as what is big data. So these words get thrown around quite a lot in mainstream, and sometimes they can be misunderstood. So let's start off with AI. What exactly is AI?
Yeah, that's a very good question, because these days AI can be anything, right? Some people have images of killer robots, Skynet, Terminator, all these things. Or other people think they're just these stupid things in video games that like you can exploit to win.
Yeah.
But really, AI is about just giving any aspect of human intelligence to some non-biological system, so artificial system.
Yeah.
So this could be something like looking at an environment and trying to understand it, or any task where you're trying to maximize some reward. So these days when people refer to AI, they usually mean machine learning. Well, that's the most popular technique these days, machine learning, which is basically coming to conclusions from data. So rather than giving your system a set of rules, say if it's green and it's got curves, it's a leaf.
Yeah.
What you do is instead you feed it a bunch of images of leaves, and then it'll learn that, okay, from all these images, these are leaves.
Yeah.
So things like that. Rather than come up with the rules, you instead use data to feed information into it, and it learns the rules. So this is sort of artificial intelligence, right? Humans can learn, so can our models.
Yeah.
So.
Yeah, I like to think of it as kind of just a new way to solve mathematical problems. It's like the problem is so complicated and involves so many different variables that it would be impossible for a human brain to go, okay, I know that if I start with this image, which an image is just a collection of pixels, I can get a 0 or 1 as to whether or not it's a leaf, which was Rahul's example. It's impossible to come up with that. So instead what we do is we try and feed in the end product. We go, okay, here's the start product, here's the end product, feed that in multiple times, and then from there you have like a reverse engineered mathematical problem that solves the model in between. And that's really all it is. It's very simple. AI isn't, killer robots. It's like, how do you identify, from handwriting what number or what letters things are, or how do you identify, speech to text, that sort of stuff. That's the stage that we're at the moment, and I know a lot of people are worried that, from there we're going to build up these huge complicated models and we're going to have Terminators. But in order to do that, our computational ability would have to, skyrocket. And I mean, there's Moore's law or whatever, but we're not increasing at a rate fast enough that we can have, Terminators with brains large enough to have that many subsystems going that we should actually be worried. It really is just a useful tool.
Yeah.
And that's all it is.
Just to add on that as well, what we call AI has been changing for the last 20 years, right?
Yeah.
Before, if you could recognize some characters, oh, that's AI, that's insane.
Yeah.
But nowadays, every pipeline has that. Anyone can do that. And now our big thing is object recognition and stuff. Wow, it can recognize poses as it can recognize you're happy and things like that. Wow, that's cool. But say 10 years, that'll change and it'll be very different. Like people want that Skynet kind of overall AI that knows everything, a sentient AI.
Yeah, so the huge challenge at the moment is self-driving cars, right? And we can identify objects on the street, but can we do that in real time fast enough so that we could then have an automated car using that data? And I think examples like that really show how big the human brain actually is, because that's exactly what we do when we're driving. We detect things almost instantly and we react to them. We do not have the computational power at the moment to be able to do that.
Speaking of self-driving cars, the recent announcements about Tesla's, how each car is actually feeding into their biggest large ecosystem, which they're calling it their AI system, is actually consistently refining their self-driving mechanisms, which is actually really cool. And this takes me on to that next question. What is big data? Because again, similar to you guys have already mentioned the word data multiple times. It goes hand in hand almost. How do you define it?
So my understanding is, now that we have the internet of things, everything's connected, and we've got these massive data centers, we have the ability to store all of these data points, from, what shoppers are buying, how people get to work, that sort of thing. and you want to find a way, like it's inherently valuable. You know it's valuable. You know that knowledge is power, but you want to find a way to use that in some way. And the only way to do that really is through AI, because you don't know the formulas that can link all of that data to a positive outcome. You need to use the AI and the machine learning to come up with that formula, like I was saying before. So that's essentially big data. It's how do we take all of these massive data points and turn that into into a positive outcome, into something that we can use as engineers. Yeah.
So essentially, correct me if I'm wrong, the data is the content and the AI is the delivery mechanism?
Yeah, exactly right.
So like AI is the machine, data is the electricity that fuels it.
Gotcha.
Without the data, the machine can only do so much, right?
Yeah.
Doesn't matter how cool a machine you make, if you don't have the data to power that machine, you're not going to get the job done.
Yeah, so for instance, social media companies are getting a lot of flack lately because they collect all of your data. They, when you scroll past things and scroll back up, they put that onto their database and they say, oh, he was interested in that. And then you'll start to see ads about the same thing.
Yeah.
It's an AI algorithm that's taken the data of the gestures that you're going on your app, what you're looking at, how long you're looking at things, and it's plugged that into an algorithm that they've trained specifically for you. And now that outputs your ad preferences, and a lot of people don't like that. That's possibly a negative part of artificial intelligence, but it is positive for the advertisers. They get to reach an audience that's more targeted.
Well, to contrast this, the big tech companies have been using data for making money and selling ads. However, why can't we use all this data that we have to do something good? Say in the medical field, we have all these MRIs, past patient records, etc. Why can't we harness that data to improve the patient care, patient's life, and improve diagnosis and all these things?
Yeah.
So it goes both ways. Right now we see the people with money. Obviously money will fuel a lot of the innovation because you want to get something out of your research.
Yeah.
But now we're making a shift to using this data for better things.
And I think it's like when humanity first invented the knife.
Yeah.
Some people figured out that, hey, you can actually skin a cat, saber-toothed cat back then. Maybe you can actually kill an adversary.
Yeah.
Or you can actually prepare a nice meal, or you can sharpen your tools. So I think we're still trying to figure out what this tool can do and what are their capabilities. So what are your thoughts on what it'll be like in, say, 20 to 50 years' time?
I mean, I think it'll improve. I think 20 and 50 years, those are two different distinct milestones. We are seeing a slowdown in the rate at which we can increase our computational power, because really that is the limit at the moment. Neural networks were discovered in the 90s, weren't they?
Yeah.
But they just weren't a viable possible solution until we had, enough silicon and small enough silicon to make these new microchips. Now, anyone who doesn't use neural networks gets laughed at, and I've copped the brunt of this because a lot of the AI I do is actually classical methods that are probabilistic, and professors say, oh no, you couldn't possibly beat neural networks, even though sometimes they do. So I mean, we're going to have an advancement in the microchip technology to expand AI, but I think, we're making leaps and bounds every day. We've got more people researching these sorts of things. The more people that are putting their minds towards the problem, the more likely we're going to come up with a new neural network architecture or a new way to solve the same problems, and we're getting more and more efficient. I'm optimistic. I don't think we're going to have AI fully taking over the world, even in 50 years. If anything, it'll just be the worst kinds of jobs that are replaced, like fruit picking, for instance. Stuff that's very easy to automate, stuff that no one really wants to do. That's the only immediate thing that's going to be replaced.
And I think one of the important things, like you said, there are very good positives to this kind of technology, and throw back to one of the episodes with the Advanced Robotics Manufacturing Hub, where their arm was actually used and coded to handle the COVID quarantine hotels, and being able to handle the laundry from end to end without any human contact, which is actually a very positive thing. So where do you think, in your wildest imaginations, in 50 years, where do you think AI might be?
So so there's a huge difference between every decade we go, right? Like anyone who's been alive for the last 10 years, we know that things have changed so much. Like the computational power of your phone is the same as a computer or laptop like 10 years ago. So things are just, as Matt said, things are tapering off a bit. We're not getting as crazy. But another thing that we have to think about is also quantum computing. Here's another buzzword I've thrown in. So if we get quantum computing chucked in the mix, things just shoot off exponentially. And then the capabilities that we're capable of changes, because with quantum computing, you can do massive amounts of computation parallelly at the same time. So it means we can properly simulate things. So this will go into, say you want to create a robot to do something. You don't have to use the real world. You can train it completely on a quantum computer that simulates the real world. And then with our advances in machine learning, you can have it do whatever you want, really. So I'll say 10, 20 years, because that's all I can think about, because after that, who knows? Like people in the 60s had some idea of what 2010 is going to be like, and it's very different. But say 10, 20 years, I think 20 years, like somewhere between 10 and 20 years, we'll have self-driving cars in Western countries, I think. Like when I say self-driving, I still mean you have to be at the wheel monitoring, because I think AI is not going to replace humans in the next 20 years. It's only going to make our lives better. There's going to be more AI tools which assist us rather than replace us. So this could mean, say you're in a construction site, you're not going to get rid of the site advisors or the tradies, but you'll give them tools to help their lives, make their jobs easier, more efficient, reduce the risk, make their lives safer, which are all good things.
Awesome. And obviously that's thinking about the future. What about the other side of the coin? Compared to 5-10 years ago, how did this industry look like 5 to 10 years ago?
Well, the difference is right here, right? So what Matt does, he uses classical machine learning techniques. I'm using more deep learning things. So deep learning is a subset of machine learning that involves these things called neural networks. So it's sort of like the brain. They're not really like the brain. The brain's a bit more complex than that. But basically, they're a set of individual units called neurons, and they're layered together, and then data is fed into them, and these neurons learn different features about the data to come up with conclusions. So usually in classical ML, things are more handcrafted. So it would be, I want to know who the best NBA player, who's going to score the most points at the next basketball game. So you'll look at, okay, time on the court, these kind of features, past scoring, things like that. And you'll use those features to come up to, you'll put those features into the model, and the model will learn from those features. Whereas with deep learning, it's more like, here's just a bunch of data about basketball games. You don't give it anything else, and it'll come up with a conclusion based on that. It's called supervised learning, where you give it a target. You give it a target for each data point, and it'll learn from that.
It's essentially the complexity of the model that's changed. So with a classical approach, you fully understand the model. It's essentially like a bell curve, but in multiple dimensions, because it's more than one axis. Very simple, but it actually works. If you use height and weight and use that to predict gender, for instance, that is actually quite a good indicator. You won't get it right all the time, but people who are taller and weigh more are usually men, for instance. But then as you want to start to identify far more complicated things, the neural network approach takes over, because we don't really know how it works, but we can just keep adding layers and layers and layers, and it becomes the most complicated mathematical algorithm you could imagine, but we use that learning to condense it. And what's interesting is we knew about all of this in the 90s. The only thing that's changed is now that we have the computational power to apply these neural networks, we have engineers and scientists working on the problem. And now that you have thousands of people working on the problem, people start making breakthroughs, and companies are starting to invest billions of dollars in data centers that can do things even faster. And that's why we've seen an expansion. The technology hasn't changed in terms of the fundamentals, the maths and the algorithms. They're all the same, but it's the computational power and how many minds are actually devoting to the task that's changed.
Love it. And how do you think these technologies are going to change the way we work compared to now in the next couple of years? How are the industries, especially the industries you guys are working in, and I'm aware that you've got a couple of different sectors that you guys apply this technology within. How do you think that's evolved and evolving?
Yeah, so especially computer vision's completely changed. So 10 years ago was like when deep learning models called CNNs first, convolutional neural networks first came up. And then back then there was this new cool thing that won state-of-the-art competitions. And ever since, things have changed so much. So first 2010, CNNs they become popular. But back then people were still doing conventional machine learning ways of doing things by looking at features and the image and things like that.
Yeah.
And then as we go in the last 10 years, things have changed exponentially. So stuff that came out 2 years ago is almost obsolete. That's how fast we're moving. Because as Matt said, there's more people in this area to innovate, and especially with software, where things can be tested wherever you are, as long as you got the hardware for it.
Yeah.
You can send some software over the globe and everyone around the world can look at it, look at the code. Like, it's open source, sorry, that's what I mean to say.
Yeah.
The research is open source, so everyone can try it. So everyone's trying the latest stuff, say, oh, this doesn't look quite right, so some other guy in India is looking at it. He comes up with something cool.
Yeah.
He publishes it.
Yeah.
And then someone in like Norway looks at it and they're like, oh, you missed this.
Combine
and then
knowledge,
we're combining everyone together.
Yeah.
Like we have the internet. We can harness the minds of the globe. And so the rate at which things are changing is exponential.
Absolutely.
Especially with the computer vision side of things.
And what are the industries you guys are currently in, applying this tech in?
So we work mostly in the defense industry. So a lot of Rahul's work is identifying civilians, from military cameras so that you can assess collateral damage, make sure that, you're not targeting, groups of people, that sort of stuff. I'm doing the geospatial analysis. So we take satellite images and terrain data, and we, detect all of the water, the roads, the buildings, and the trees. And then from there, so that's an AI model that's produced that. You can then populate a 3D world, and you can start doing mission planning with that sort of stuff. So you can start plotting paths. You can say, okay, if I've got an unmanned ground vehicle and I want to get from here to here, what's the most optimal path? Avoiding water and trees and buildings and following roads, or staying out of sight of the enemy, that sort of thing. So at the moment, it's a very military tactical level, but that's how most advanced technologies actually start. If you look back since the beginning of time, you're working for the military, but there are so many civilian applications. For instance, we've recently put in a proposal that was a similar thing to that geospatial analysis, but for disaster relief. So if there's been a bushfire and trees have fallen everywhere, can we take a quick satellite image, run that through geospatial AI, and then go, okay, what's the fastest evacuation route from this location? Now taking into account that the roads are blocked and that there's flooding, for instance, or there's a fire over here. That sort of stuff.
Love it.
Yeah, and similarly, even though we started in the defense space, we can easily do anything that involves vision, right? Because as long as the models are the same, it's just the data that's different. There's some tweaks that you have to do, but it's the same principle. So instead of looking for civilians, we can look for, say, fruit or starfish or things like that. So there's many applications, and the applications are endless. Like, we can use this in every industry. Say construction. You want to make your site safer, so you can have something that looks for, say, hard hats. If someone's not wearing a hard hat, you sound an alarm. Things like this. And that uses the same vision principles. It's a bit more you have to add, of course, for the whole application. But
it's transferable.
It's transferable, yes.
Taking this conversation into a little bit of a different tone. You guys are relatively new to your careers. How long have you been in the working industry so far?
So I've been working full-time for a year and a half now, a bit more than a year and a half. And then for a year and a half before that, part-time while I was at uni. So not very long, but it's been kind of a similar sort of field. It's this advanced engineering, small company sort of stuff.
And your tertiary education was how long?
5 years. 5 years. So I have a master's in Mechatronics Engineering.
So I've been working for 2 years. So Athena AI is my real first proper company, because before I was working at the uni doing research, which is very different in terms of...
It's still a company.
But I was working 12 to 8. I could choose my hours. No one. It's just weird. You're more free, and things are a bit slower maybe. And here there's deadlines and things we have to do. But before that, I did bachelor's degree in 4 years. Bachelor's with honours. It's built into engineering degrees in Australia. But,
look, the reason I asked that question is you've had your high school and your university career was around the corner. What are the subjects, what are the skills that you learned during your education that have actually helped you succeed in your career now? Let's start with high school.
So high school is really the fundamentals. So, I mean, we were both fortunate enough to excel at maths and science, and that's led us to this career. As a coincidence, we both went to the same school. And they didn't offer computer science. They really should have, but they didn't. But you know, if you have the fundamental mathematical background and you have the fundamental physics background, it is easy to quickly transition into computer science. You know, there are definitely a lot of students in first year who had that exposure at school and they do get a head start, but it's not too detrimental. I mean, you know, if we had it for years before, then that would be, you know, a big advantage.
Yeah.
But definitely, you know, of course you have to be able to read and write and, you know, communicate, but there is a big focus on maths. And if you're not excelling in maths at high school, it really isn't an avenue that you can consider, I wouldn't say.
Yeah, fair enough. What about you?
I think you can, like, maths isn't the be all and end all of this kind of stuff, right? Because right now we're getting to a stage where you don't have to understand the maths as much with AI.
Okay.
If you can do a bit of coding, you can make things work. Obviously, if things go wrong, you're in a bad spot. You're in a bad spot.
Yeah.
But to make things that work, you don't need the maths, but you do need critical thinking. You need to know how to source data, how to go and, like as Matt said before, how to go on Google to get information about something. Say I want to make a robot. Or we can go Google, there'll be plenty of tutorials, plenty of videos, whatnot. So I think the most important thing in high school education is critical thinking, learning what's a good source of data, what's a bad source of data, that kind of thing. Like, and also learning how to learn. That's another important thing, meta learning. Because, like, if you can learn how to learn, you can pick up anything theoretically, right? Well, we've got a limited amount of time in this. People have different things they're more inclined, or they're better at, they have a better aptitude for certain things. But you want to learn these meta skills rather than the actual content. Well, you do want to do well in school. I'm not saying not ignore your classes or whatever.
How you learn the meta skills, right?
Yeah, the meta skills are more important. That's yeah.
Cool. And how do you think creativity plays a role in this?
Well, I've
design thinking, for example.
Yeah. So there's always this thing of like, oh, creative people do arts, creative people do this. We shouldn't really promote that, I think, because there is lots of space for creativity in mathematics and all these things. Like, just thinking art is creative is nonsense. Design
There's a lot
is
of creativity in software development.
Yeah, exactly.
Absolutely, yeah.
Yeah, I mean, for me, creativity is, I've learned all of these things in the past and they're kind of like just little points in my brain, and you link them together to create something new. That's essentially creativity. So it's not necessarily, okay, here's an awesome new painting or a piece of music that I made. Of course, that's creativity. But from I'm focusing a lot on maths. From a mathematical perspective, there are certain things that you've learned sometime in the past, and the way that you apply them to new problems is the creativity that I use in my field, at least.
Yeah, and I think that's the common misconception, where people think if it's not a piece of artwork that we can physically see that's got paint on a canvas, that's not really creative. But you're absolutely right in saying, I think when someone is developing a new piece of software, the level of creativity that goes into designing that, there is a lot underestimated, and it's just not on the surface, but it's there.
And all the jobs of the future are going to focus on creativity. That's that's what AI is going to replace. It's going to replace the non-creative things first, the things that are simple and easy and repeatable, and then it's how you use all of those things that it's found creatively. That's going to be the human input, at least for the next 50 years, I think.
Absolutely.
Yeah, just touching on the art thing as well. Like, for engineering-minded people, the iPhone is a work of art, like the first iPhone that came out.
Absolutely.
Like, there's lots of products that are art, but we don't think of it because we think of painting, we think of music. But you can, like, these things are beautiful in like an engineering point of view, because creativity is what drives people forward, right? It's when we make new things in different ways, we can come up with better solutions. Because yes, things in the past work, but we don't have to deal with that standard. We can always keep innovating, always go to the next thing. And also, if you're a creative person, come up with a cool startup. There's money in that too. So, that's where the money is. Creativity is where the value is.
Yeah, absolutely. And I'm very happy to hear that, given the work that we're doing, and most of the listeners are schools and teachers, so they're going to love what you're hearing. So here's a bit of a tough question. You guys are indirectly within 21st century education as a classification in the time period. Do you think, in a very clear, plain sense, it aligns with the requirements of the industry as of 2021?
I don't want to be too hard on them, but no, absolutely not.
Okay. Why do you say that?
I think there's way too much focus on the humanities. I mean, I'm biased. I'm in a STEM field, but Yeah, I mean, you just have to look at the numbers of people graduating law and arts, and these are smart kids, you know. They graduate school, they go to university, and they're ready to learn, but they just don't have the interest or the background in doing STEM-related fields, and that's what we need. That's the modern economy.
Yeah.
We don't need any more lawyers, I'm sorry, guys. We need more data scientists, we need more engineers, and I do think that fundamentally starts at primary school and high school. So, I mean, the biggest issue is there aren't enough women in STEM. Half the team isn't even playing, and that's why there's such a big shortage of supply, and there's so much demand for these kinds of skills. But more than that, I mean, it comes from the same issue. We're not encouraging people enough. When they're struggling with maths, we say, oh, well, you're just not mathematically gifted. And science is coming out now that there's no such thing as being mathematically gifted. It's just someone's told you that you're not mathematically gifted.
Yeah.
And now you're going to go down a different route. You're still a very intelligent person, but now you're focusing more on your humanities. I think we need to make sure that we're, you know, progressing all skills evenly all the way through high school, and really hammering home, you know, this is the modern economy. These are the skills that we need for the future. You need to be scientifically minded. You need to be creative, not just in an artistic sense, but also in a mathematical sense, that sort of thing. That's where I think the education system needs to go. It doesn't necessarily need to have all these fancy new gadgets in the schooling system, but the fundamentals, the grassroots, they really need to be established, and kids need to understand why it's important.
The thinking and the approach, you mean?
Yeah.
Just to add on to what Matt said, yeah, he's right. We're not equipping high school students to excel in these industries. Because number one, the way we're thinking about things like coding, right? We think, oh, that's like software engineering. When no, coding is just a better way to, it should be thought of as computer literacy, just using computer. Because that's basically what you're doing. You're just giving more functionality to your computer.
Yeah.
So coding is not just reserved for software engineers. No, it should be not just engineers either.
Yeah.
Like even now, you know, chemical engineers, electrical engineers are learning coding. But not just that, everyone, even lawyers.
Yeah.
It should make their lives easier. You shouldn't wait for some software engineer who has like a law friend who knows about the field to come up with a new thing. You can do it yourself. And I think, well, Matt said it's not that important with all these gadgets and stuff. But I think what they do well is they can inspire people to do things, right? Because when we first learned maths, we're like, oh, just a bunch of numbers. Like, what am I going to do with it?
Formula, right?
Yeah, just a formula. Like, what's the point of the quadratic formula? I'm never going to use it.
Yeah.
But really, what we should be showing them is the end product, and then working our way back.
Yeah.
So we can show them, hey, if you know a bit of maths and a bit of coding, you can make this cool AI system, robot, or whatever.
Yeah.
And then work back. What are the things they use?
Yeah.
So more of a top-down approach of learning.
Yeah.
So same with all kinds of
And
fields.
I think there's a lot of value in what you've just shared, because it's inherently proven that people will pick up on logic-based thinking and mathematical equations when they can visually see that, and virtual reality has played a big hand in that. So there's a lot of value in that. So I love that you both bring almost complementing but slightly opposing views as well to the same topic. So that's really good. Now, what's your advice for students and graduates right now?
Yeah, well, I was about to actually segue onto this if you didn't ask that question.
Yeah.
There's also this big stereotype that's going through uni that all the things that you're learning you don't need, you don't use, you learn on the job.
Yeah.
And I've had the complete opposite experience. Yes, there's a huge amount of learning on the job, but every single time I've been working and, you know, a little light bulb goes off in my brain and I'm like, oh, I remember that thing I learned and I've applied it. That's led to something really good. So I think what's happening is people are handicapping themselves by saying, I'm not going to really focus that hard at uni. I'll just get 4s and I'll go and work on a mine site somewhere. Yeah, there are some jobs within engineering that don't require you really to remember much from your uni, but the new and exciting jobs, yeah, I mean, the more you can learn and the more you can remember, of course, you're going to be exposed to more interesting work. And that's just the reality of it. So I think a lot of people get shut down early. They hear, you know, they have bad mentors and they say to them, look, don't worry about it. You can make, you know, 6 figures if you just don't even focus on your degree. Well, sure, but if you want to be a creative mind, you know, pioneering the future of technology, no, try and remember every single thing. You'd be surprised all of the random knowledge that then can get mixed together and come up with something brilliant.
Well said.
Well, my philosophy is a bit different. I think you shouldn't be constrained in school. If you want to learn something, the internet exists. Go learn it. Don't wait for the third year subject in uni or something to learn about something. If you're in year 10, you like AI, you can go learn about it. Okay, there's going to be some things that are very foreign to you. There's going to be weird maths, but you can learn it in steps. First, you see the end product, and I said before, go work your way backwards. Okay, there's this maths. This builds on this maths. Okay, this is similar to what's it called? Calculus. I learned in grade 10.
Yeah.
So I can bridge the gap of that knowledge and work towards it.
Yeah.
So what I promote, what I'm going to say to kids in high school, in the early years of uni, just if you're interested in something, go look at it, go try it. It is a bit daunting at first where you see things, but you want to be trying things because the beauty of the internet is everything's out there.
Yeah.
So we want to harness these. Even teachers, tell your students, like, if you don't quite understand something, they're asking you difficult questions, you can look it up and you have a bit more knowledge that you can maybe, not necessarily teach them it, but show them how to get there.
Yeah.
Because it's about the path.
Facilitating the learning.
Make consistent learning part of your life, right? Yeah.
And which actually goes on to my next question. What's your advice for teachers, mentors, educators?
Teachers really need to, I think, I mean, this is, I'm kind of hammering this point a lot. They need to focus on the stories that they tell their students. You know, if you're telling students, oh, you know, this isn't on the test, they're not going to remember it. If you're telling students, you know, you're a C student in English, you're not good at English. You're a C student in maths, you're not good at maths. That becomes their internal story.
It becomes their reality.
Exactly. Yeah. The teachers need to encourage students that everything is important, everything that they're learning is important, and use what Rahul was saying about, you know, show them the end product, say, if this is something that interests you, here is the journey to get to that point. And just because you're, you know, at this very low level now does not mean that you can bridge that gap by just doing your own research, doing your own learning. Like, you know, for a grade 1 kid, you know, can barely read, but a grade 12 kid who's getting C's for English would be getting A pluses in grade 1, right? And that's, you know, that's a big gap, but that's 12 years of knowledge condensed. You know, if you can get from that level, the grade 1 level to the grade 12 level over 12 years, what if you accelerated that twice as much? Think about where you could be in 6 years' time. There's no reason to feel like because you're behind now that you have to stay that way. If you're interested in something, if you're interested in that end product, put yourself out there and focus on it. And I think that's what teachers should be encouraging.
Beautifully said.
Yeah, well, how am I supposed to follow that? Yeah, just adding on, you know, push, like, inspire the kids, show them what's possible, and don't put them into boxes.
Yeah.
Show them you can, these days, you can be anything, really. Like, people are changing careers. There are people who are like 30, 40, just jumping into AI.
Yep.
So the education's out there. And also, like, you don't have to be 20-something to understand AI, or 23 or whatever. You don't have to go through that many years of education. Like, you know, there's 15-year-old PhD students, right? Like, as long as you inspire the kid to go in that one direction that they're interested in, they can learn what they need to.
The amount kids are learning about video games these days, if they just, you know, directed that energy into something else.
And I think that's valuable. It's because of the perception of this kind of field, these kinds of technologies involves almost a beautiful mind. It's almost unattainable for everyday people.
Yeah,
so
every
people
mind is a beautiful mind.
Yeah. There you go. That's, I think, the perfect way to summarize that.
Another thing I want to add also to inspire the children to get their hands dirty.
Yeah.
Get them doing things. Like, if they're interested in AI, tell them to start actually building things, right?
Yeah.
Because that's where you learn. Because what happens is you'll look it up and you'll be like, okay, this is maths, this is that. But it's not until you start doing things that you can actually learn it. So just encourage the kids to get dirty, try things, fail quickly, and then move on.
Perfect. Now, you guys have mentioned Google as obviously the place to go and learn, but are there any other sources you can recommend if people want to go learn about AI or big data? What are your thoughts?
I mean, yeah, Google's getting a lot of brand rap here, aren't they? I mean, they're the ultimate search engine.
Are there any books, are there any shows, websites that you might recommend?
Yeah, so I'm going to say, especially for AI ML, I think everyone, I say 80% of the field right now, they've done this course.
Yeah.
It's on Coursera. It's taught, it's intro to deep learning, and there's also intro to machine learning.
Yeah.
Like, it's a course that you can do. You can do it for free, like you can watch the videos for free, but to actually get the recognition, you got to pay for it.
Sure.
So I'm going to suggest free sources because that's what I use.
Yeah.
Like I obviously have my uni education to give me that extra tick.
Yeah.
But there's a lot of free sources out there. Like there's lectures from Stanford, MIT, all these top universities, you can find on YouTube.
Yeah.
You just have to be careful you don't get lost in the YouTube algorithm.
Yep.
But YouTube's a good source. Like Google and YouTube, same thing, right? As I said before, you want to learn how to find information, what's quality information.
Yep.
So if you have these skills, Google becomes a lot better. Like you know what a good link is. You know how to follow it to get good information.
Yeah. Perfect.
Yeah, I was about to add YouTube to that list, but you beat me to it. If you're looking for something less technical and just want exposure to what's possible, there is a lot of awesome stuff on YouTube. A lot of those science channels, a lot of those computer science type channels where you've got a programmer who's has the code linked in the description, but they're really just showing you how they've built. For instance, game development is a big one that I use because I'm using game engines to do my virtualization. A lot of the tutorials, they're building really cool things in this game engine. They're showing you how they started, what didn't work, what did work, how they were persevering, and you kind of, it builds a storyboard of what the experience will be like for you and how you can actually enjoy that journey. It's a lot of hard work, but then at the end you learn a heap and you get that code to go along with it if you want. So that's definitely a good resource.
Yeah, so a specific resource, because I know YouTube's broad, there's lots of things. Number one, Khan Academy. I'm sure most people have heard of Khan Academy. It's got me through high school and uni. There's another one called 3 Blue, 1 Brown. So it's a good YouTube channel that explains mathematical concepts with visualization. That's a very important thing, right? Because sometimes we get lost in the maths, the symbols, but we want to actually see what we're calculating, things like that. So that's a good channel.
Yeah, I mean, if you're in early high school and you want to be awesome, go on Khan Academy and learn all of year 12 maths. There's nothing that's stopping you. You don't need to have an older brain to have a bigger brain. And you know what? Then you'll start getting A+ for everything and life will be easier for you. So that would be my best advice. I wish I did that.
Beautifully wrapped up, man. Beautifully wrapped up. Well, thank you so much for your time. You guys have absolutely killed it. I think it's been one of the most informative and fun conversations. So thank you so much, personally.
No worries.
Thanks for having us.
Here.
Pleasure.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto rashansenanayaka.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Rashan Senanayaka. Till next time.